in many situations. Number one, I want to find out effectiveness of one test, right? So we will, we will conduct some test. We will find out the score. Then we will give the teaching. Then after that, for example, this program. So first we have asked you to perform some statistical knowledge, conduct a statistical test. Now from the same people, okay. So after this program, conducting the test, what is the marks, right? So we can compare these two. We can find out, because it is a marks metric variable, we can find out mean, and if we can find out mean for this variable, and we will compare, and we will find out whether there is a difference. If there is a difference, which means when there is a mean difference, then the teaching has produced the effect, right? That is number one. Number two, this is before and after. Now, see, for example, I want to show two advertisement. I want to show two advertisement. I want to know which advertisement is very effective. So first I will show one advertisement. I will ask 100 people to give rating, right? Same set of people, right? That is why same, right? Another advertisement is shown. Just ask the opinion rating. Find out whether these two ratings are different. Then we can find out which advertisement is better. So like that, we can find out, apply for anything. But the matter is, we are taking two metric variables. That's all, right? So whenever we say two metric variable, this variable is also from the same person. This also from the same people, right? That is why. So this is a dependent test, right? So now let us put let me take salary now, what they are getting. Salary in the beginning, before joining this organization. So what was their salary, right? So now analyze, compare means, very simple test. Compare means, parity test, right? So salary in the beginning, right? Salary now. Okay, so say okay. Since we are taking two variable, it will produce correlation also. We are not interested in correlation. Now let us go here, right? See, there is a difference. Okay, so the significant value is 0.00 t significant value. So which means there is a difference. There is a difference. So now,
sir, the output sheet is not visible, sir. We can see the SPSS file. The output sheet is not visible.
Okay, so now is it visible, madam?
Yes, sir. Yes, sir. Yes, sir. It is visible, sir.
Sir, your voice not audible, sir.
So now here the significant value is 0.00, right? So which means there is a difference. Okay, so which means before salary and after, now what is their current salary? There is a difference, right? So the salary in the beginning is 17,000 average. Salary now is 34,000 average. So which means after coming this organization, so there is a huge hike in salary. So we can say that this organization is a good organization. So they have increased the salary, okay, to the double. So almost double in the sense. So it is not for one individual average. So this we can tell this organization is good organization. That is the final inference. So now one more also I will do. Right. So now I am taking another data set. Okay. So now I'm taking new data set. Let me share. Okay. So now I have, see, now let us look at another. So how, where PRT test can be applied, right? See, now the companies, they announce a dividend. The companies, they announce right issue. Company, they give bonus shares to their shareholders. So the company is taking a lot of steps. So whenever they announce the bonus shares, why they are announcing the bonus shares? To increase the shareholders' wealth, because that is their objective. So what do you mean by increase the shareholders' wealth? To increase the share price, simple, right? So they want to increase the share price so that wealth of the shareholders will improve. So they do all these things, right? So now we want to see whether announcement of result, company has given a good result or bad result, whatever it is. After the announcement of result, whether the share price has increased, right? So now what happened? So the share price is taken for the same company for the last, before announcement 10 days, after announcement 10 days share price we have taken, right? Before announcement and after announcement, we have taken 10 days. So two columns, simple, two columns, both are metric variable. See, that is what we are taking. That is the periodicity test, right? Two columns, both are metric variable. So that I can find out mean, I can compare. That is this one. So where, okay, so many applications you can think of. So now, okay, so now let us produce, analyze, compare means, right? Periodicity assemblability test. So first we'll put a B1 before, right? Then A1 after. Okay, say okay, simple. Say okay, very, very simple test. Right. So now let us look at the T value, right? T value, right?
Recording in progress.
So it is 0.00, which means there is a difference. There is a difference, right? So 0.00, which means there is a difference. So now there is a difference in the mean. Whenever there is a difference, we should not stop. We should find out whether share price increased or not. Now look at, before the average share price is 817. Now the average share price is 760. So which means it has come down by, it has come down by 56 rupees, right? There is a reduction in share price. Okay, there is a reduction in share price. So there is a significant reduction in share price after the announcement of result. So the result has produced a significant change in price, but the price has reduced. So which means probably the result may not be good. So we have to look at the result. Okay, so if the result is not good, then we can say that there is a bad result. Because of bad result, the price has come down very heavily. Significantly, the price has come down, right? That is what. Otherwise, if the result has improved, from last year, the result has improved, but the price has come down. Why price might have come down? See, people might have expected a very good result. So already they might have taken the price up, but the result announced is not to their expectation. So the price has come down. So like that, you have to analyze and you have to tell more and more points. But here what it will say, we are taking two metric variable, right? Okay, so whether it is before result share price, after result share price, or what we have before salary, after salary. So we are going to take two metric variable and we are going to compare the means. Whether means are different, we are going to see. So now depend upon the what is the metric variable we have taken, we have to give the inference. Now here there is a significant reduction, significant change in the mean. That is what 0.00. how it has changed. Before mean is 817, after mean is 760. So the price has come down, right? So probably the result may not be good, right? So this is the paired sample t test, right? Very, very simple test, very, very simple test. But many places people use, especially scientists, so especially medical field, education, all the people they will use, they want to prove whether particular teaching method is good method, whether the particular tablet is good, or whether this treatment given is produced effective result. So because without giving, see, you have a tablet, right? So we will give tablet to them. So before giving tablet, what was the fever? After giving tablet, what is the fever? Fever, what is the temperature? Whether the temperature has come down. So when the temperature has come down, then we can say this tablet is producing an effect. Very good. Okay, so this is what the paired sample t-test, right? So if you have any questions, you can ask. Otherwise, I will proceed. Okay, so next is the, okay, so now, right. So here, compare means independent sample t-test, paired t-test, ANOVA VSC, all comparing the means, find out whether there is a difference. Okay. So now let us go to the general linear model. Okay. So general linear model is a multiple model, this one. Now we will go for a repeated measures ANOVA. Repeated measures ANOVA. So now, why this repeated measures ANOVA? Right. See, for example, when you go to doctors, they will give tablets. They will ask you to take 3 times, 3 days. They will give some antibiotic and they will ask you to take 7 days. Right. Okay, 7 days, 15 days, 20 days, like that. For different tablets, they will give different dates. Sometimes, okay, so they will come again to the doctor. Doctor will ask, okay, what happened? So whether you have taken the tablet regularly, he will ask. In this point, gentleman might say, no, sir, I have taken 3 days, sir. The fever has come down, sir, so I have taken. The doctor used to scold at them. I have asked you to take 7 days, yeah. We have stopped with the 3 days. No fever. No. They will shout at them. See, why they are asking the patient to take 7 days? Because already when they have produced, they have tested. So, okay, so it will produce effect till 10 days. Okay, you have to take, so it will reduce. After that, there will not be any reduction. So they will take, they have given the tablets and they have tested. The mean value might have come down. So now, so it is having effect on 10 days. So that is why they have to take 10 days. So how they are prescribing based on this repeated measures ANOVA. Right. So this is one example. Okay. So the idea is we are going to take many metric variable, many times taken. Okay, otherwise many metric variable, same respond. Whenever we say metric variable, same respondent. Now let us take one data. Right. So now see here, these are metric variable. Okay, so measured in 10-point scale. Okay, so 4 times 4 metric variable. Okay, I am going to find out mean for this one, mean for this one, mean for this one, mean for this one. I am going to compare. That is what I am going to do. This is called the repeated measures ANOVA, right?
So we are not able to see the screen, sir.
So now I have 4 metric variable. I have 4 metric commercial one, commercial two, commercial 4 metric variable. Okay. Otherwise, it is taken on at 10 point. Okay, which is scale? 10 point scale, right? One is very appealing.
ರೋಹಿಣಿ ಮ್ಯೂಟ್ ಆನ್ ಎಂಟ್ರಿ ಅನ್ನೋದು ಒಂದು ಬಟನ್ ಇದೆ ಪ್ರೆಸ್ ಮಾಡಪ್ಪ.
10 is appealing, right? 10 is appealing. Okay, so 10 point scale measured. So it is a metric variable. So the idea is, right, to look at the data, 4 metric variable I am taking. What I am going to do is I am going to compare mean of this one, mean of this variable, mean of this variable, and the mean of this variable, whether the means are different or not. Okay, so that is what the statistics. Now what is the application? Now, so we are showing the 4 advertisement to the same set of people, and we have asked them to rate each advertisement for commercials. Okay, so we want to know which commercial is good, whether the particular commercial is significantly different from other commercials. So that is what we are going to see. Okay, so now whether the means are different or not, but it can be applied to any situation. 4 metric variable, right? Comparing mean. What variable you have taken, based on that you can write the inference, right? So now, okay, so analyze only 4 metric variable, nothing else, right? Analyze. Okay, general linear model, repeated measures ANOVA, right? So here you can put default, it will give factor 1. So we can give anything, right? We can say commercials. Okay, commercial. Any name you can do, because I feel it is commercial, that is why, right? But this is very important, right? We have taken 4 times. This is very, very important, right? So measures name, add rating. Okay, it is rating. Anything you can give, but not necessary also. This one, not necessary also. So only thing is this you need to give, the 4 you need to give. Okay, then define. Okay, so define. Now, so this since we have typed add rating in the down, it is coming here. If you are not typed add rating in the down, that commercials, whatever you are typed in the front, it will come. So, okay, commercial one. So put 4 all, okay. Okay. Now, right. So this here we have a result. Here we have a result. How to interpret this result? Okay. So now the significant value is significant, which means there is a difference. There is a difference, right? So now, now here there are many methods. Sphericity assumed. Okay, Greenhouse-Kaiser, Kind-Felt, and lower bound. We have many. We have many. So which one to see, right? So for that, we have to look at the earlier one. Okay, so for that, we have to look at this earlier table, right? Okay. So now this is called a Matchley's test. Okay, so they have put the null hypothesis also. Null hypothesis is the covariance matrix is identical. Okay, so there is no significant difference in the variances. Okay, in the variances. Okay, so that is called the okay. So the variances, okay, so variance of 4, okay, so all are not different, so all are same. Okay, so that is what the Matchley's test. So when the much least test, okay, so now how to write this one, right? Commercials. Okay. So the sphericity condition is where the variances of the differences between all combined, otherwise the sphericity. This means that population variance of all possible different scores. So commercial 1, commercial 2, commercial 1, 2, 3, commercial 1 and 2 and 3. Okay. So this minus this. Okay. So we'll find out the differences. So that differences and that is the covariance. Okay. So covariance and okay. So that is equal. Okay. So variances of all possible differences, all possible different variances of differences of all combinations are equal. So that is what, like it is like the homogeneity test. It is like a homogeneity test. So the distribution is similar. That is what okay. So the mean value might be different. So when you plot this distribution, so when one distribution is like this, another distribution is also like that. Okay. So the variances are equal. So that is what we are talking about it, right? So it is like a homogeneity test what we have performed in ANOVA, right? Here it is a sphericity. Okay, that is called the sphericity, for which we use the much least test. So we use the much least test. So sphericity can be liked to the homogeneity of variances between subject and ANOVA, right? Which is similar to that. So now okay, so now if you go here, okay, so okay, so we want the variances should be equal, right? So the null hypothesis variance is not equal, right? So we want okay, so variances are not different. Variances are not different, right? So which means variances are equal, right? So we want, okay, so variances are not different, which means variances are equal, which means we need to accept the null hypothesis. We need to, the variance should be equal. So we should accept the null hypothesis. So here the significant value should be greater than 0.05. The significant value should be greater than 0.05, right? It should be greater than 0.05. Okay. So if it is greater than 0.05, which means the sphericity is assumed. Okay, equal variances is assumed. So the sphericity is assumed, right? So we want to assume the equal variances, right? So now it is assumed. It is assumed. Then now let us go. Okay. So now, okay, now we have to look at sphericity assumed, right? See, normally what we want is, okay, so null hypothesis here, this should be, okay, accepted. The sphericity or equal variance should be there. Otherwise, earlier we used to say you should not use it, right? Now we have many robust tests. Okay, if it is, okay, it should be, this is the condition, right? So it should be accepted, sphericity, right? But now we have many things. Right? Even if you do not have, okay, so if you have the sphericity, okay, assumed, then you use sphericity assumed, this significant value. When the sphericity is not there, otherwise the significant value for the sphericity is greater than, is less than 0.05, right? So which means equal variance is rejected. So there is a heteroscedasticity. Then we have to look at the Greenhouse or Heinfeld, right? So now we have accepted. So we have to use the sphericity assume. So now this is there is a difference. So the other things I will come later. So now there is a difference, which means the four means are, the rating given are different. Okay. Four ratings are different. Now, okay. Now, okay. So now look at, we want to know, okay. We want to know, we see there is a difference, right? So we want to know which rating is a good rating, right? So we have to look at the mean value, right? We need to look at the mean value. தம்பி சொல்லுங்க தம்பி. சரி 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 தம்பி. ம் சரி 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 தம்பி சரி ஓகே சரி ஓகே தம்பி ஓகே ஓகே தேங்க்யூ. So okay, so here in the options, okay, we have descriptive, okay, we have descriptive, okay, then we can compare this one, this also. Descriptive also we can see, this also, point for also we will see. Okay, so now we can see the commercial one, the average rating which they have given is 4.15 or 10 point scale. Second, okay, third and fourth, right? So now from this we can understand the fourth commercial is better. Whether each one is completely different, each one is different or not, we will look at the, okay, we will look at the comparison, right? Pairwise comparison, right? So the rating given to 1 and 2, there is no difference, right? Rating given to 1 and 3, there is a difference because the mean value is, okay, so 4 point something, right? So look at the mean value 4.1, right? This is marginal mean value, okay, so 4.1, 4.9, 6.1, 6. Okay, so 4.15. So first to 4.15 and 4.95, there is no difference, but 3, 6. So that is why we can look at the pairwise comparison and we can see whether they are different, right? So 2 and 3, 1 and 2, there is no difference, significant value greater. 1 and 3, there is a difference. 1 and 4, 2 and 1, there is no difference. 2 and 3, there is a difference. 2 and 4, there is a difference, right? 3 and 4, okay, so there is no much difference. 3 and 4, 6.2, so there is no much difference. So 1 and 2, there is no difference. 3 and 4, there is no difference, but there is a difference. So that is what it is. That is what it is telling. So see, what we can do is, okay, so now, okay, so first time, okay, for we have asked them to kick, okay, whether there is a measure for 100 people. Okay, then second time, third time, fourth time, then we can find out whether first performance and second performance, whether there is a difference. Second performance, third performance, whether it is a different. Third and fourth. So if you have taken from 100 people, we can find out where the difference is coming in, So we can find out where the difference is coming in. We can find, right? Okay. So now, so okay, so we have compared the mean and we could see where there is a difference. So overall there is a difference. So this is overall. Okay, so now one more what you need to know is, okay, so now here we have greenhouse Kaiser and Hein. So when we have to use greenhouse, when you have to use Hein. So for which, okay. So now see when the Machli's test, right? We have told it should be greater than 0.05. If it is greater than 0.05, there's porosity assumed, right? That we have to see. So when it is less than 0.05, okay, we have to go for some robust test. Okay. So what are the robust tests? We have Greenhouse. Okay, Kaiser. Now if if the Greenhouse Kaiser is less than 0.05, then we have to use this one. When it is more than this one, then we have to use this one. Now let us go here, right? Right. Suppose, see here. So we have Machli's test. So here this is greater than 0.05, then we have to use the sporosity assumed. Here we have to use the sporosity assumed, so that we have to see this value, right? So degrees of with the degrees of the F value is 15.372 with the degrees of freedom of 3 and the degrees of freedom of 3,117. So there is a difference. Suppose okay, if suppose if this value is less than 0.05, then sporosity is not assumed. Then we have to look at the greenhouse. So when the greenhouse, okay, when this greenhouse, if it is less than 0.75, then we have to use the greenhouse. Now here it is more than 0.75, then we have to see the kind, right? If that, okay, so kind we have to see this one. So when, okay, the sporosity significant value is greater than 0.05, we have to use this one. Okay, if it is less than 0.05, then we have to look at the greenhouse. When the greenhouse is less than 0.05, use greenhouse, otherwise use the kind. Okay, otherwise use the kind. So this is what the 4 commercials, right? So for commercial, this is the repeated measures ANOVA. See, many times, many theses I've seen. Okay, so people have used Friedman test. Friedman test is the non-parametric test for this repeated measures ANOVA, right? So people do not have any understanding of this test, and they have used Friedman test. Okay, so now we will take the another data set. Okay. So here 3. Okay, so okay, we have shown 3 cars, right? We have shown 3 advertisement for one particular car. 3 advertisement with 3 entirely different theme.
So data screen not visible.
Entirely
So the data screen is not visible, so we can see the output.
So now, okay. So now we have 3 advertisement. Each advertisement is talking about. So it is for one car, right? So in one car, the advertisement is talking about it is a family car. So another advertisement, it is talking about the okay. So it is talking about the youngster car. Then third one is it is talking about environmental friendly car, right? So it is rated in a, okay. So it is rated in a starting from 0 to 100, right? Okay, so 0 to 100, it is a rating scale. Okay, started with 0. So it is a interval data. Okay, it is a scale. Okay, interval data starting from 0, right? Level 0. Okay, so 0 is not having 0 meaning, right? So now, okay, so now we have another one gender. So the another one gender where we have taken okay 0 female and 1 male, right? Very good. So now Now, right? How I'm three advertisement, right? Now let us see. Okay, three. See, so let's see the data. Three metric variable, right? We are going to find out mean and compare. Same thing, but some new point I'm going to tell, right? Same thing, right? Comparing the three means. So analyze general linear model, right? Repeated measures ANOVA. So here we'll put here. Okay, we'll put what we'll put. Okay, so attractiveness. Attractiveness. Okay, so here let us not specify anything.
So why three?
Hello? Hinama, yes?
Sir, you can continue, sir.
Define. So this three is the ad rating, right? So now I am going to put gender here. Gender here. Gender is between, right? Two groups, right? That also I am going to do. Okay. So now, so first we have to see the Matchley's test. The Matchley's test is okay. So 0.264. So which means parasity is assumed. Okay, there is a homogeneity of variance. There is a equal variance. Okay, so okay, then okay, we have to look at, see, is parasity assumed. So the all three ratings are different, right? So all three advertisements, the mean of mean rating given to three advertisements are different. So because as far as calcium we are seeing, then we have this attractiveness and gender. There is a interaction effect also. There is an interaction effect also. There is an interaction effect also, right? So now first, okay, first we will see, okay, three ad. First we will see this one. Okay, so how they are different. Then we will look at the other one, right? General linear model. Repeated measures ANOVA. Okay, defined in the options. Okay, so this we will put first attractiveness, right? Attractiveness, right? First we'll put the gender and attractiveness. Then then we will see this one, right? This also will put why then this also will put. So now, okay, so now, So on an average, okay, all three rating together, right? Okay, it is not one. Okay, all average for female 67, all three rating. Okay, so there is no difference between male and female, right? So there is no 67 and 67. So you can see male and female, there is no difference. So now when you take all rating together, right? So when you put, for example, overall score, okay, so what is given, then overall score if you have put, and if you have done, okay, then there is no difference between male and female. So that there is no difference between male and female overall. Okay, so probably in one people might have given, male might have given more, in one female might have given, we do not know. Okay, so when they've taken overall, okay, so there is no difference between male and female, right? So that is for a overall mean score 67, 68, there is no difference. Okay, so now we look at the attractiveness. So first advertisement 83. Okay, what is that advertisement? So family car, right? Family car. So that advertisement, okay, whether male and female all together, right? One advertisement. So okay, overall mean 83 because 100, right? 0 to 83. Okay, another advertisement average, it is 56. The youngster car, okay, many people they don't like 55. So the environment friendly car, that advertisement they like to the extent of this one. So now we will look at whether they are different. Okay. So 1 and 2, there is a difference. 1 and 3, there is a difference. 2 and 1, there is a difference. So if it is less than 0.05, you will say there is a difference. Now the interestingly, okay, so this is the important. Now we said there is an interaction effect. Take a look at this. Female, right? So for family size car, they have given a very higher rating when compared to male. See here. This is this one, this is one, right. So now there is no much difference in 68 and 63 too. So now two for the youngster car they don't like. Okay, so if you saw this is a younger car, all young children might ask, then female they are okay, mothers they are worried. Okay, don't show this is a younger car, so they're not liking. So okay, so now when you take our one low, see here, they have more, right? Here they have more, first one, here less male, right? But here it is less, here it is more. So that is why when you take overall average there is no difference. So now if you take each people with respect to each advertisement, so there is a difference. So this is called joint. Okay, within female, within three advertisement there is a difference. Within male, this advertisement there is a difference. Okay, so this is interaction effect we can see by looking at. So we have noticed. Okay, so here. Okay, so we have noticed that. Okay, so Sparacity assumed there is a difference. Okay, the difference in the interaction effect, right? So now interaction effect can be seen by using the, already as shown by using the diagram, right? Let us use the diagram also, right? Okay, already there. Okay, so now plots, plots. Now see here, right? Okay, so now we can see. So whenever these lines cut to each other, then there is an interaction effect. Now see here, okay, male, right? For family car, younger size, it is less, but okay, so the difference is little less only, right? Only here there is a difference, but there is no difference between these two when with respect to male. But when you look at this one, so for this younger car, they have given more, but no, this family car. But this one, they have, so that is why it is cutting. Whenever these lines cut, then from by looking at this one, we can tell there is a whenever the line cut, we can tell there is a interaction effect. There is a interaction effect, right? Okay, so look at four means. Okay, so if the point is look at the Machli's test. If it is greater than 0.0, that is what we want. Earlier, when it is greater than less than 0.05, we will not use. Now this software, many people they are working. Many people they are working to find out robustness. So when it is greater than 0.05, sphericity is assumed. Equal variance is assumed. If it is less than 0.05, equal variance not assumed. You have to go for a greenhouse. Okay, so greenhouse is when it is less than 0.75 greenhouse, more than 0.75, then high. Okay, so that is what we have to see. Whenever there is a difference, we can find out. Now we are looking at the interaction effect because we have put one category variable as a between subject. So we have put one between subject. Okay, so like that we got many more output. You can see very interesting things also you can see, but minimum these things we have to report. Minimum these things we have to report. Whenever there is a difference, you should not stop. You should say who is having more, who is having less, how they are different. Okay, interaction effect means where there is an interaction is taking place. See, for example, the younger car. Okay, so between younger car and family size car, the female they are given a higher rating for family, and younger they are less than this one. So there is a interaction. Okay, so this is what the repeated measures are. This is what the repeated measures. Right now, if you have any question, you can ask a paired test. So we are completing all compare means. Hello, any doubt?
So Vivek Gupta has raised his hand. Yes, sir, you can ask the question, sir.
Yes, Vivek Gupta, sir, you can
Sir,
ask.
sir. Good evening, sir. Am I audible?
Yeah, I could hear you, sir.
Right, sir. Sir, is this interaction effect same as the mediation and moderation effect, which is generally talked about, or the mediation and moderation effect are different? Means we'll study them separately, or this interaction effect is the mediation?
Simple. Wait, sir. So now I appreciate that you have written some knowledge, sir. So now the mediation is different, sir. Mediation is different. The moderation is the other word for moderation is interaction effect, right? So the interaction effect is nothing but the moderation, right? So now in normal moderation, especially in AMOS, we will use one categorical variable to find out the moderation effects. So here also we are using the categorical variable, right? So gender is a categorical variable. So we are using one categorical variable and the one metric variable to find out the interaction effects. So interaction effect, joint effect, moderation, all same.
Okay, sir. And mediation effect is different.
Mediation is different. Mediation is entirely different.
We'll study that, sir.
No, sir. That and all. Now here only up to regression we will see, sir. So the mediation and all I have to teach with the AMOS or PLS, smart PLS or listening.
Right. Sir. Okay, sir. Thank you very much, sir. Thank you very much.
Thank you, sir.
Sir, there is one more question from Sudikshna. Ma'am, you can ask your question, ma'am.
Good evening, sir.
Good evening, madam.
Sir, one question I had, sir. Like you were talking about the various robust tests. For example, if homogeneity is not there, we go for other robust test. If variance is there, we go for further robust test. Sir, earlier it was said that if it is not homogeneous, you increase the sample size. If there is heteroscedasticity, you go for a larger sample, it will go. So is it true, sir, or we have to go for I cannot relate that what is this robust test actually, and like they say that by increasing the sample size all the problems are solved, but now various tests have come to do whenever it is non-parametric. So how the two are related, sir? Can you just
see, the idea is right. Whenever you have less sample, right? Normally, this problem will come, right? See, for example, take normality. Take normality. See, when you take only 2, right? So one person might say 4, another person might say 4. There is a possibility. So, which means all 5 point, there is no point, you may not get it. You may not get it. But when you increase more sample, then you will get some people who might have ticked 1. Then if you might be getting some people who might have ticked 3. Right. So there is a chance of people selecting the all combinations. So it might result in the normality. That is why people used to say, when the sample size is more than 200, see, for example, there is a central limit theorem. What is the central limit theorem? See, when you increase the sample size beyond 30, okay, so your mean will tend to reach the population mean, right? See, the idea is very simple, right? You have estimate, right? You have, see, certain things you need to understand very, very carefully. One thing, let me tell. You have used that word also. You have parametric test and you have non-parametric test. When we will use parametric test, when your assumption is met, that is normality assumption is met, you will go for a parametric test. When you do not this one, then you will go this one, right? So now, when assumptions are met, right, then your estimate, whatever you are getting, whatever the value you are getting, the mean value, right, variance, whatever it is, that estimate will become population parameter. So what do you mean by population parameter? So this can be when you take the when you take the entire population, you will get that mean. Though you have collected certain variables, certain people, you have calculated a mean, right? So when you take for the entire population also, you will get to that mean. That is the meaning. That is the meaning. So when you have taken the normality, what do you mean by normality? All. Okay. So all possibilities covered. So by this side also, it is meeting the assumption, right? So your estimate will become the population parameter. So that is why. So, but when you use non-parametric test, your estimate will be estimate only. It cannot be generalizable. So when you write any paper, by using non-parametric test, right? When you write any paper by using non-parametric test, so if I am a reviewer for an international journal, then definitely I will say don't publish this article. Okay, I may not look into other things because this will be applicable only to your sample, not to the universe, not to the population. So that is why the applicability of non-parametric test is not that much. So you should go for the parametric test. That is number 1 point. Number 2 point, see, the central limit theorem says when your sample size is more than 30, then your estimate, your mean, your estimate will be okay. So your mean will become the population mean. So which means it can be applicable. So, but that is the worst. Okay, so 30 is very, very less. But whenever we say the population is more than 200, or definitely if it is more than sample is more than 500, so we will not check for any assumption. We will not check for anything. We presume that it will meet all assumptions. It will meet all. We presume, right? So if you put anything, your all assumption will be met. That is the idea, right? That is the idea. Okay, so when you have larger samples, then okay, meeting assumption will not be a difficulty. That is why they say whenever your sample is more and more, okay, so you need not worry about it. The idea is when your sample size is more, meeting assumption will not be a problem. Will not be a problem. That is why they tell like that, right? That is why they tell like that. So now here, look at okay. So now see here itself, right? See, my scholar, I have asked him to prepare the PPT. He has prepared this PPT. So in which, see, okay, much least test, right? Much least test, right? Okay, so now see here. However, this assumption is not needed if the sample size is greater than 25. Okay, there is sporacity, all these things, right? So these are all hypothetical. These are all we presume, right? So whenever you, okay, so whenever whether irrespective of sample size, you perform these assumptions, right? So when the assumptions are made, okay, this one. So now, for example, see, they are estimated, right? See, they are making adjustment. They are making adjustment in the standard error and other things. So that, okay, so they will produce okay, so to make adjustment to this problem, right? Whatever problem you have, in the robust test, they will make adjustment to take care of this problem, right? That is why we are going for a robust test. That is why we are going for a robust test. So robust test is no way related to the sample size, right? Is it okay, madam?
Yes, sir. Yes, sir. Thank you. So, sir, you are suggesting that it is not very advisable to use robust test all the time.
No, you have to use. You can use definitely. Definitely, you can use. No one can see you are wrongly understood, madam. You are very, very wrongly understood, right? So if somebody has used robust test, no one can question. It is scientific. It is adjusted for the problem.
Okay. So, sir, the answer which the robust test will give will actually be the answer of the population also?
Yes, definitely. Definitely.
Okay. Okay. Thank you, sir.
So there is one more question from Dr. Vivek Gupta. He has raised his hand. So you can unmute yourself.
Sir, thank you so much, ma'am. Sir,
Yes, sir.
one more question is there, sir.
Yes, sir. Yes, sir.
That is not related to these tests. That is related to basically the collection of the sample. Sir, nowadays, we most of these scholars are collecting data through Google Forms. Now, Google Form is not a probability. It's not a kind of probability method to collect the sample because no probability is getting applied here. Another thing is it is neither a judgment sample nor a convenience sample because you don't see the respondents. right? We expect,
sir, wait, sir.
Sir.
Yeah, I know all sampling techniques. Okay.
Sir.
But okay, even my scholar, she was using. Other day, I was discussing with her. So whether you are taking, how you are sending, all these things. So definitely, she is not using any convenience. At the same time, we cannot call this as a random, right? For some of the people, we have not given a chance, right? So, but the sample is more. There is no bias, also. There is no convenience, also. So
Yes,
I'm okay. I have asked here to find out whether anybody has suggested suitable the right name for this sampling technique, right? I have asked to find out, sir. So as far as at present moment, I do not have knowledge on that, sir.
So means on the basis of this sample, we can do rest of the analysis. Means is it acceptable or not? I just want to just kind of, because you are the senior person, your guidance will help us to collect data, because many of the times it is not possible to take the one-to-one say responses.
No, see, one thing, please understand, sir. See, for example, don't go for the for example, your friends, right? Your friends suggesting. So that kind of snowballing effect, try to remove, sir, right? But see, for example, you have sample frame. Sample frame means you have list of customer taken from somebody. Okay, so you have list of population. So from which you have taken the mail ID without applying your bias, without applying this one. You have sent it to all mail IDs. So then you have collected data. Then if our sample size is more than 384, so definitely it is acceptable.
Okay, and if we don't have any sampling frame in that case, because in some of the studies, suppose you are getting you are targeting to collect data from across these states, where you don't have, of some respondents for which you don't have any kind of sampling.
Some see, any research, some kind of sample frame you have to take, sir. All right. Somewhere okay, you go to the brokers, or for example investors. So you go to the brokers, or you go to the NLC website, find out some lists, find out some things. That list may not be good. So your bias should not be there, sir. That is my objectives.
Right. So means sampling frame is required. If sampling, just one situation when sampling frame is not there and from open you are collecting the data. So your sample is coming from the population, but you don't have the sample frame.
No, how do you say it is coming from the population, sir?
Because suppose you have put certain conditions.
The question is how you are sending, sir. How you are sending? How you have selected the mail ID?
Not mail IDs, through Google Form, say through
Google
WhatsApp.
Form you will send it. Now, how you will send the Google Form, sir? Through WhatsApp or through mails, right?
Mails, right, sir.
So you might be having mail ID, no, sir?
Okay. Yes, mail IDs. Yes, mail IDs are there.
How you have collected?
Okay.
So
Now, mail IDs
for example, like, sir, see, you have sent it. If you send it to your own friends, right? Your own friends' mail ID. So that is the problem, sir. That
becomes biased.
That we cannot say you are collected from the population, sir.
Yes, sir.
See, for example, you have collected from these, okay. So you collected the list from this Sivakumar, sir, right? So
yes,
they're all not known. You can, this sample, this can be a sample frame. If you have attended workshops, right? So they're not your friends, okay. No. So we can take this as a population, this is a sample frame.
Okay, right. Okay, some list has to be there of email IDs or something,
yes,
which are not your friends.
Yes.
Right. So thank you so much, sir. So it can be used. Means no biasness is there, so it can be used.
Now, see, this is a modern technique. We have to accept any modern technique, sir. Yes, so probably we have to change the literature to accommodate this one, sir. So somebody might have already done, sir. Already might have reported. So that is why she is using. I have asked that girl to find out the appropriate this one.
Okay, sir. Okay. Thank you so much, sir. Thank you so much. Thank you, sir.
Okay.
Hello, sir.
Okay. So now we'll go to the next one, sir.
Hello, sir.
Yes, sir.
Yeah, sir. First of all, thanks for the session, sir. Sir, I have some generic queries. Let us say that in a classroom, I want to, there is a fan or maybe AC, which has some 5 settings, let us assume. And there are some 100 people. So one person may say that setting 1 is better. Second person may say middle one is better. So likewise, there are 5 levels. If we assume and there are 100 respondents, can we use similar techniques, sir?
Pakka, sir. No issue. No
Okay.
issue, sir. See, sir, we are taking mean, sir.
Okay.
Okay. So one might be more, one might have given good, one might have given low. Average only, sir.
Okay, sir.
So average will take care of everything, sir. So when we say average, it takes higher value or lower value also.
Okay. So this is applicable to...
See, whenever you have this kind of metric data, first you have to remove the outlier, sir. Without removing outlier, if you perform, so your mean value will be distorted, right? So that is why we are trying to, whenever you have metric variable like this, figures, right? See, if you use 5-point scale, no problem, sir, right? But whenever you have income, whenever you have all these things, so metric variable, okay, so such kind of ratio scale, we have to remove the outlier, then, okay, irrespective of when 5 metric variable, you can compare, sir, no issue, sir.
Okay, sir. Thank you, sir. And also this SPSS, although it is named as social science, but it is also used in all the scientific, it can be used, right? Scientific.
Yes, sir. What is the problem, sir?
Okay.
What is the problem, sir?
Sir, and one more generic query is typically...
Can be used.
Yeah, typically multiple tests. Once I want to go into depth, I should be going for multiple tests, right? I should not be satisfied with one test.
No, sir. See here, one thing you have to be very, very clear, sir. Right. See, many people, they are doing mistakes, sir. Right. What mistake they are doing? In fact, one sir has asked me, so whether I can use metric variable for a chi-square test. So metric variable, probably he might have meant the 5-point scale, right? See, when you use a 5-point scale as a categorical variable, then once you have treated one variable as a category, then in one another situation, you cannot use that as a metric. That is prohibited. It is 100% wrong, right? So once one variable, when you have treated that variable as a category variable, so in some other occasion, you cannot use it as a metric variable. That is not possible. But one metric variable can be converted and you can use as a category variable. So I will tell how can be converted. Okay. So that is number 1. Number 2, 2 tests for a same thing, it is not advisable, sir. So 2 tests for same thing, it is not advisable. But here we are not using 2 different tests, sir. We are not using 2 different tests. So within the test itself, we are generating more information, sir. It is not a different test, sir. Right. So within the test itself, we are by performing minor, some more this one. It is not different test. That is the other options, different options available in the same test, sir. Okay. Okay. Whenever you use test, whatever possible you can perform within test, it is available within the test itself, sir.
Okay, sir. Okay.
So now, though I have not told everything full with repeated measures and other things, all are available, sir. All are available, sir.
Okay, sir. And we would like to take your email ID maybe later after the FDP so that for any queries we can mail you in later, sir. And your expertise is really very, almost everything, sir. That is the great thing that we are able to get a lot of things from you, sir. Thank you, sir. Thank you very much.
My mail ID is, don't wait for this one. Now itself, you please note it down. My name is Kasilingam, sir.
Yes, sir.
My name is Kasilingam, right? I'm working with the Department of Management Studies. So kasilingam.dms
DMS. Okay, sir.
at gmail.com. That's all.
Thank you. Thank you very much, sir. Thank you.
Okay. So now, okay. So I'm going for very, very important thing. So that is recursion, right? So now the recursion I will teach today. Tomorrow also, okay. Many days I require 3 or 4 days to teach recursion alone. Because for all, you need to perform recursion, right? See, publishing papers with chi-square, all these things difficult. So you can use MANOVA and higher test. Okay, fine. But okay, so people expect the recursion. People expect the recursion because that is for the future. That is for the estimation, right? So the recursion is very, very important, sir. Understanding recursion is very, very important. Okay, so today I will teach certain things. Tomorrow also I will take up, okay, mainly, okay, if you could understand the binary logistic regression, I will be happy, right? I will teach binary logistic regression. And we have neural network within the regression itself, So if you could understand all these things, I will be happy. Okay, there are many regressions, then we will see. Okay, so please try to understand, right? Okay, fine. So now let me go to the regressions. Okay, so first of all, right. So now I got two metric variables, right? I got two metric variables. Okay.
Sir, the screen has not changed.
Sir? Excuse me, sir.
Yes, madam.
Excuse me, sir.
Yes, madam. Yes, madam.
Sir? Sir, we could see the PPT but not SPSS data file, sir.
Yeah. So
Sir,
now,
your PPT is visible.
Now
data view is visible, sir.
That is what I want, sir. Right. So you got total income, total savings, sir.
Yes, sir.
Yes, sir.
That is what you want, sir. So now I've taken two variables, right? I've taken two variables. So one is total income, another is total monthly savings, right? So both are no options, no values are given. So here also it is mentioned as scale. And if you look at the data itself, we can understand, okay, so all different values, so I can find out only mean. Okay, so now I have two variables. One variable is total income, another is total saving. Right. Now, right. See, whenever I can perform, whenever two variables metric, I can perform correlation, right? So I can compare mean also, but that is not necessary. Okay. So two entirely different variables, what total saving and the total income. So what is this of comparison, right? No use, but they're all related, right? So add rating 1, add rating 2, we can compare the means. We want to find out which one. So here, right? Though it is, but you can perform parity test, it will give result, but there is no logic in it. Okay, so now I want to perform the regression, right? So now the purpose of regression is to find out the influence of one variable on the another variable, right? The purpose of regression is to find out the influence of one variable onto the other variable, right? So the variable which is influencing the variable which is influencing, we call it as the independent variable. The variable which is getting influenced, we call it as dependent variable, right? So in a regression, we are using the new terminology that is called the independent variable and the dependent variable. That is the one, right? So now, okay, so now independent variable influence the dependent variable, right? Otherwise, why we use normally, we use y-axis, right? Y-axis dependent variable, x-axis independent variable, right? That is why x is independent, y is dependent, all right? Okay, very good. So now let me perform the regression linear. So now saving and income, we need to know which is dependent and which is independent, right? So saving is dependent, income is independent. We believe saving is depending on income, right? So, okay, so now we will say we are not touching anything, okay? We are not, first, okay, how I have learned is, okay, so first I will put like this. Then we will try to understand this is the minimum, all right? Then we need to go one by one. We need to go one by one, right? How each one we can do, okay, like that. Okay, okay. Now, right, total income. My objective is to find out whether income influence the savings or not, right? That is my objective, first objective. Now, okay, so this is hypothesis. So here, okay, I'm going income, right? I want to know whether income is influencing the savings. So that is why I'm coming here. So I'm going to income, straight line. Now I'm looking at this significant value. I'm looking at this significant value. So this significant value is less than 0.05. When it is less than 0.05, I can say this variable is influencing my dependent variable. So I can say my income is influencing the saving. That is the first point, right? So it is less than 0.05, so it is influencing. So that is the first point I can tell, right? Now, the second point is you can look at the t-value also. Now, when the t-value is right here, when it is less than 0.05, there is an influence. So when you look at the t-value, when the t-value is more than 1.96, right? When the t-value is more than 1.96, which means there is a influence, which means there is a influence, right? Very good. Here it is 10.351. So there is an influence. So both will give same result. You cannot give different result. So we can look at this one and we can look at this one also. Right. Fine. Now, right. Now. Okay. So I will tell how the t-value is coming. All right. How the t-value is coming. Here, okay, here is a beta. Right. So this is the beta. This is the beta. So this t-value I will come later. This is the beta. This is the A, right? Now we need to know regression equation. Regression equation is y equal to A plus bx. Y equal to A plus bx. right? Okay, so my regression equation is y equal to a plus bx, right? So a is called intercept, b is called the beta or regression coefficient. So now I already have explained a. So a is the point of intersection, right? So I have told you what is the meaning of a. So now when x is zero, when x is even if x is zero, even if x is zero, so when x is zero, bx will become zero. So you will get y is equal to e. So irrespective of x is zero, you will get some y. That is called a. So we can say a is pre-written, or otherwise even without studying you will get some marks, that is a, right? So without the even nothing is available in the independent variable, you will get something, right? That is called the a. Okay, so now what is b, right? Already I have explained. Okay, so beta. So now beta is when there is a 1 unit increase in x, right? When there is a 1 unit increase in x, what is the unit increase in y? That is called the beta. So when the beta is 2, right, which means when you increase x by 1, y will increase by 2, right? So 2 times of increase of x will have impact on y. So the beta is talk about the extent of influence. What extent x is having impact on y. So that is the beta. So the beta is more and more important. That is the important estimate to us. So that is why the main purpose of regression is to find out not only whether there is an influence or not, it is to find out the extent of influence. So the extent of influence, the answer to extent of influence, we can get it through beta. So that is why we call beta as a regression coefficient. Beta is a regression coefficient. Beta is very, very important with respect to regression. So now we can write the regression equation, right? We can write the regression equation. Okay. So how to write the regression equation? So there are many things. Okay, so okay. So now this is the output. This is the output, right? 3,281 and 10, all these things. Now y is equal to 3,281 plus 0.161. This is the beta, right? Y is equal to a plus bx, right? So here a value is constant, right? A is 3,281.033. Beta is point beta, otherwise unstandardized beta is 0.161. So this value, so y is equal to 3,281. Point I am ignoring, plus 0.161 into x. So let me put a value for the what is the variable name y. Y is equal to monthly saving, which is equal to 3,281. So 0.161 into monthly income, right? So we can write the equation, right? We can write the equation. So beta is our estimate here. Beta is our estimate here. So beta with the help of estimate, we are finding out the writing the regression equation, right? Okay. So now, this t, right? Now it is this t. So this t is this estimate divided by standard error. Here our estimate is beta. So beta is divided by standard error is the t value, right? So this, okay, you can put it as a common, right? So estimate divided. Okay, for example, already I have discussed in a skewness estimate divided by standard error. That is the t value. For example, in the independent sample t-test, the difference we are trying to find out difference whether the difference is significant. Here we are trying to find out our beta is significant, right? So okay, so beta divided by the standard error is the t value right here. Right? Okay, so now, okay, so this divided by this one, right? So now, one thing, right? See, we have written the null hypothesis, right? How statistically to write the null hypothesis? See, we say in independent sample t-test, there is no difference between one mean another mean, right? Okay, so what does it mean? No difference, both are equal, right? Right. When both are equal, difference is zero, right? Which that is why we say that difference is zero. So that is why we say mu1 minus mu2 equal to 0. Otherwise, x1 bar minus x2 bar equal to 0. The difference is 0. Otherwise, mu1 equal to mu2. Right? The statistics people, they write mu1 equal to mu2. That is the null hypothesis they will write. They will not write there is no difference. Okay, they will write mu1 equal to mu2. So what mu1 is a population mean x1 bar, right? Equal to x2 bar, which means x1 bar minus x2 bar equal to 0, right? So in a correlation, R equal to 0, right? We already seen, which means no relation. Here in a regression, no influence, which means beta is 0. When beta is 0, what will happen? Right? When you increase the x, right? Okay, so whatever may be the x into beta 0, everything will become 0, right? When beta is 0. So which means even when you increase y is equal to a plus bx, please understand. When beta is 0, what will happen? So irrespective of what is the x, 0 into x, that will be 0. So which means the x is not influencing, right? Where the increase in x is not having effect on, that is why beta is 0. But beta, okay, it will have something, right? So beta divided by standard error is the t value. So in ANOVA, difference divided by standard error, right? Okay, so correlation also yesterday as I have shown, right? T value is equal to, right? R into divided by standard error, but the standard error formula will vary for different, okay, so different tests, right? So I think we have understood this values, right? So how the slope is calculated? What is the t value calculated? Okay, so what is the standard error formula? Okay, how the intercept is calculated? All we have the formula, right? So all we have the formula. Then I will teach one more important thing. One more, not important, right? Having spent 10 days, we will try to understand this one, right? So everywhere, if you have noticed, whenever I have shown any output, everywhere you might have seen lower bound or upper bound. Hello, Nandini madam.
Hello, sir. Good evening, sir.
How are you, madam?
Sir, I'm fine, sir. Due to heavy rain, I was unable to join. Sorry, sir.
Okay, very good, madam. When some people are talking, so
Yes, sir.
coordinators, please mute them, madam. All right.
Yes, sir. Yes. Sir.
I request all the participants kindly mute yourself.
Okay, so
I know you are in the session, but kindly take care of all the technical aspects.
okay. Thank you, madam.
And one more thing, sir, with your permission, one more thing. People will attend the session. The session is going to end at 8 o'clock. Till 7:45, you people are joining the session. So kindly stick on to the time so that you can get more knowledge and you can have a very good knowledge about if you attend from the start, from 6 o'clock. So don't attend in the end of closing ceremony or in the closing of the session. Thank you, and kindly mute your mic and switch off your videos before attending the session. Thank you so much.
Okay, very good, madam. Thank you, madam. Thank you so much.
Thank you, sir.
Okay, so now this see every day. Okay, till the end, some people are coming. I do not know how are they coming, right? So it is really disturbing here because here black is coming. So I'm moving the screen here and there. Okay, because I've asked you to make not to co-host, but when I'm not co-host, I'm not able to present. Okay. Okay, very good. Okay, let us not waste time. So because already time's up, I have to discuss more about recursion, right? So now this everywhere when I have shown any output, you should have noticed the upper bound and the lower bound, right? Now, okay, it is very simple, very simple, right? See, first we will go to the descriptive statistics. So from then onwards, we will try to understand what is this lower limit and upper limit, right? So first, okay, so everywhere it will be same. Then I will come here, right? Certain, okay, though it is not okay, very much important. Okay, having attended okay so many days, if you know certain statistics, I think it will be better. Okay. So we will put the age of the employer. Okay, so I have taken the age of the employer, right? Only one variable. Okay, so analyze descriptive statistics, explore, right? Explore age, right? I'm not using anything else. Explore, right? So now you have okay a mean value, right? You have mean value. You have lower bound and upper bound, right? We have taken only one mean, right? Only one variable mean, right? So now how to find out the upper bound and the lower bound? So this mean here, because we are finding the upper bound and lower bound for the mean, only one variable, right? So we have estimated mean, right? So now I want to find out lower mean, a lower bound and upper bound. So the mean plus or minus 1.96 into standard error, that is the lower bound, upper bound. So now 42.07 plus 1.96, you know what is the value of 1.96 into this standard error, right? So let us assume that 1.96, 2, right? 2 into 0.5, which is equal to, okay, so approximately 0.6, right? So it will be 0.12. That is why 43, right? 42 plus approximately 1 point something. So that is why 43.22. Lower bound is 42.07 minus, right, 1.96 into standard error. That is the lower bound.
Nice.
Right? So when we estimate mean, the lower bound mean or mean plus 1.96 into standard error. Upper bound, lower bound is that mean minus 1.96 into standard error. So this is with respect to one variable, mean, lower bound, upper bound. See, now we will go to the, okay, so we'll go to the, all everywhere it is same. That is why I am going and I am telling, right? So everywhere I can tell, okay, so now let me go to the independent sample t-test, right? Average monthly minutes. Compare means, independent sample t-test, enter 0 and 1.
Screen is not visible, sir.
Screen not visible, madam.
Not visible.
I will come. Whenever I open, I have to share this thing. So average monthly minutes, this is what we have done when we have discussed, right? So now, right? So here I have put gender, right? I have put this one minutes. So to find out whether they are different, male and female, they are independent sample t-test. So compare means, right? So let me perform again. Okay, so analyze, compare means, independent sample t-test. So minutes, which is a metric variable on the top, gender, which is a categorical variable, right? Different groups, 0 and 1. 0 and 1. All right. So now compare means we are going to compare the means to find out whether they are different or not, right? So now look at this one, right?
பரிச்சயமா நாளைக்கு தப்பு தப்பா போட்டுருக்கு.
Okay. So now, okay. So now, first point, let me tell. Okay, we have told you, right, the difference. Here we are looking at the difference, mu1 minus mu2. We are looking at the difference. So 160, 163, 160 minus 163, 3, that is why minus 3. So minus 3 divided by standard error, minus divided by 5, right? 3 divided by 5, this will be 0.5. That is why T. I have told you, no, estimate divided by standard error. Here, what is our estimate? Difference. That is what we are estimating. We are estimating the difference, whether the difference is significant or not. That is what we are trying to find out. So we are estimating the difference, whether the difference is significant or not, we are trying to find out. So the difference divided by standard error is the T value here, right? So now here, that is one point, right? So now another point is lower bound, upper bound, right? So automatically it is there, right? So I have told you that difference, right? The difference, so that is a minus, right? Right? Minus plus, right? Plus 1.96 into standard error. Here, what is the standard error? Standard error, right? 6, right? Okay. So minus, right? 3 plus, right? So almost 1.96 into 6, right? Okay, so 12. Okay, so 12 minus 3, 8. 8.5, right? So, okay. So now this one minus lower bound is minus 3 minus 1.96 into this value. So say, okay, say 12. So this one, that is why 14. Okay. So now, okay, this will be useful. Many places you may not be having this one, then significant value, right? I have told you when both are plus, there is a difference. When both are minus also, there is a difference. Now here, 1 minus 1 plus, that is why significant value is, we have to look at this one, right? Significant value is greater than 0.05, which means there is no difference. Here, lower bound, upper bound, one is minus, one is plus. So now you know how to find out lower bound. Now we will go to our SPSS, our regression, right? I will go to regression. So now recent versions, okay. So the upper bound, lower bound, all will come automatically, but in my system it is not coming. So only regression coefficients is there. Confidence interval, let me click, right? If I click the confidence interval, right? Now you can see the earlier up to significant value, right? So now you can see the lower bound, right? Now, see in a regression, what we are doing, we want to find out influence, right? Where we are getting the answer, whether there is influencing beta, right? When beta is 0, there is no influence, right? When the beta is significant, there is a significant influence. So whether there is a significant influence or not, we are deciding based on beta. So beta is our estimate. So beta divided by standard error is the t value, right? So now lower bound, upper bound is this beta, right? 0.161, right? Plus, right? Plus 1.96, 1.96 into standard error, right? That is the upper bound. Upper bound. So the lower bound is this beta 1.161 minus 1.96 to this one, right? So now here also we can tell when here both are lower bound, upper bound is both are plus, so which means there is influence, right? So we can look at many things to say whether they are influenced. We can look at the significant value. When the significant value less than 0.05, there is influence. When the t value is more than 1.96, there is influence. When the lower bound and upper bound both are plus or both are minus, there is an influence. So many things we can tell to say whether there is a influence or not. Whether there is a influence or not. Right. So now we have seen this value and this values, right? All these things, right? Okay. So now, right, I need to explain. Okay, so with the formula, all these things, if necessary, I will explain tomorrow. But next is next. Okay, first, whether there is an influence or not. Second, we are writing the equation. Third, what we are doing is, see, it is a prediction technique. We are trying to predict y. We are trying to predict. See, when you know the equation, y is equal to, right? For example, saving is equal to 3,200 something, right? When you write the equation 3,281 plus 1.61 into income. So if some people, when they say they give their income, you substitute X, then you can find out their savings. So we are predicting, right? It is a prediction. So we need to know what extent we can predict, right? Because the saving is not depending upon one variable. It is depending on many variables, right? So the saving will vary because of many variables, right? But because of income, how much the saving varying, right? See, we are trying to predict the savings, right? So what do you mean by predicting? So the saving is varying from person to person. What extent it is varying because of this income, right? So the income is, that is why we call income influence, right? Which means when the income is changing, saving also will change. That is a relationship, that is an influence, right? So now what extent we can predict, that we need to know. That is called the R square, right? That is the R square, right? So here the R square is okay 0.163. 0.163, right? So which means the changes in Y or variability in Y can be predicted, right? Only the 16% with the help of this independent variable income, right? R square is degree of determination. What do you mean by degree of determination? What extent we can determine Y with the help of X, okay? What extent variability in Y can be predicted with the help of X, right? What extent changes in Y happens because of income, right? So the income 16, otherwise let me tell other way. 16% of saving is dependent upon the income. 16% of the saving changes is due to the income, right? So that is the degree of determination under the R square, right? So adjusted R square is, I will explain tomorrow with the formula. So by adjusting the number of, here we have only one independent variable, so there we need not worry about much. So by adjusting the degrees of freedom because of changes in number of independent variables, right? So we are adjusting the degrees of freedom. Okay, after adjusting what is R square, so it is a adjusted R square. It is a adjusting the changes in degrees of freedom, right? So now whenever the number of variable changes, so here the regression, okay, this one, the degrees of freedom will be 2. When you take 2, the degrees of freedom will be 2. This will be okay. So degrees of freedom is 1. So to that extent, we will make adjustment in the R square. After adjusting what is the R square, that is called adjusted R square, right? So adjusted R square is more precise, more okay. So more precision. Okay. So now next is this ANOVA table. Why ANOVA table you are getting? Why you are getting ANOVA table? Right? So now what will happen? See, many places people are struggling. Why they are struggling? See, for example, we say R square is 0.16. So which means degree of determination 16%. Only 16% we are determining. Right? People used to say, right, only 16%, whether it is sufficient or not. Okay, so you need not worry about the absolute value of R, right? You need not worry about absolute value of R, right? So by adjusting the, okay, so all degrees of freedom and other things, sample, okay. So look at the F value, look at the F significant, right? If F is significant, we are significantly predicting the changes in Y, right? See, our idea is we want to predict the savings, right? It changes because of many variables. So whether I am predicting the significant changes in saving, right? When ANOVA is significant, which means we are predicting the, okay, we are predicting the saving, okay, changes in saving significantly. We are significantly predicting. So our model is right. Our model is okay. So we are saying whatever variable included is sufficient. Whatever variable included is sufficient. So all answers you are getting by looking at the significant value. So always ANOVA value you have to report, right? F significant, F value along with the significant value you have to report. So you have to report T value and the significant value, and the with the help of unstandardized beta, write the only with the help of unstandardized beta, please write the recursion equation, and okay, report R square and adjusted R square, and okay, so report this one. So these three are very, very important, right? So now we have R, right? We have R. The R square is R square of R. When R itself is not significant, then R square will not be significant, definitely. Okay, when R is not significant, R square is not significant. So now R is relationship, right? So now it is, okay, when it is two variable, no problem, right? Okay, so now I will try to find out this R, right? How to find out this R. Now, I'm saving the unstandardized predicted value. Okay, sorry. Unless, till last minute, people will come, right? Almost 8 o'clock, people are coming now, right? Very good. Okay, so what to do? So unstandardized predictive value, residual also, okay. The distance, all are important to find out the. Now I have saved two. This is the predicted value. What is the predicted value? Y equal to A plus BX, right? So with that equation, we have A value, B value, right? So include the X for every X, okay? X is income, right? So take this income as 44,000. A is 3,281 point plus 0.161 into this one, then you will get to this value. This is the predicted value with the help of equation. Now, the R is the relationship between the, okay, so dependent variable and the predicted. Okay, so now let me find out correlation. Okay, saving and the predicted savings. So we can see 0.404, right? So that is the R value. That is the R value. So R is relationship. We know it is 0.404. R is a relationship, right? If it is two variable, it is a relationship between dependent and independent. That is fine. But if it is a multiple recursion, right, you will be having many R. So the R is, but you will get only one R even for a multiple recursion. So, okay, R is relationship between dependent variable and the predicted dependent variable. That is the R, right? So now, okay, the residual is predicted. Okay, so actual, okay, predicted, okay, minus the actual, right? So that is the error, right? So this is the actual value. The 13, this is the predicted value. So actual minus predicted is the residual, right? That is the residual. So now we'll see the, okay, so we'll see the graph also.
Excuse me, sir.
Over, madam. Completed, madam. Completed. Okay, I have to ask the question also.
Yes, sir.
Okay, so that I will do it tomorrow. Okay, so now that's all. Okay, so now if you have any, I will add some more flavor. Okay, to this. Okay, so many more flavor I will do. So I will do that. Okay, so I will do that. I have to send. I have to send this PPT. Then only you will go through this PPT and you will come back. So with all these things. Okay. So now if you have any doubt, you can tell me.
Participants, if you have any doubt, you can just raise your hands so that you will be given chance to speak with sir.
Hello, sir. Once again, thank you, sir.
Yes, sir.
Sir, my query is, you said R square is 16%. The effect of, in the example, effect of months. Does that mean that, as per my understanding, there are other factors approximately remaining out of 100?
Yes, yes, sir. Yes, sir.
Okay. So should we also explore that in that case?
See, sir. See, one madam has asked me, right, sir?
Yes.
See, when, for example, okay, when the homogeneity is not there, right? Then, okay, if we increase the sample size, the problem will be solved, sir. Okay. So, of course, okay, when you increase the sample size, that problem might be solved, right? But we might have already completed the data collection, sir. Right? So how can you go for more samples, right? It is difficult to know, sir. So that is why we are going for robust tests. So now what will happen? See, already you might have decided data, all right, variables and all you might have decided in the beginning. Then you might have put questionnaire, you might have collected data. Now if your R square is less, see, that has happened, sir. The adjacent to my room, there was one scholar, he was a little old scholar. So his R square was 0.4. One of the engineering faculty, he has asked him to R square is less, you go for it. Another data collection. Now that person has cried because so now identifying new variable, going to that same people, collecting data, is it possible, sir? Okay, so that is why, okay, you can explore, sir. No doubt about it. You can explore, right? But with this variable, you cannot explore. You have to add a new variable.
And one more question is, does this particular software is very popular, or maybe others, any of the software is almost the same in terms of interpretation?
All are same, sir. See, normally I used to perform. See, for example, now I'm using SPSS, right? See, when I teach Amos, the first exercise, what I will do is I will perform regression here. I will perform regression there in Amos. I will say both are same. I used to teach E-views also for secondary data. There also, here I will perform regression. There also I will perform regression. I will show both are same, right? But this software is having this analysis. Amos, right? When the all results are same, sir. If you perform regression here, perform regression there, the software cannot produce different result. It should not produce, it cannot produce, it will not produce. But that software is meant for some other purposes also, sir. See, for example, Amos, apart from regression, you can perform mediation and other things, structural equation you can perform. In E-views, you can perform auto regression, but auto regression, all these things, it is not possible here. Okay, so like that, okay, meant for different purpose. When you perform same test here and there, all will produce same result.
Okay, sir. And one last question, sir. You talked about outliers in the initial classes also, and also does it come under data cleaning? And do you also talk something on that, sir, somewhere?
No, see here, sir. I used one outlier cleaning with the help of standardized, right? So if it is a metric variable, clean it and perform. Now here also, there is the Mahalanobis, right? Our own statistician. So he has given some contribution. It is available in the regression for data cleaning, outlier detection, right? So I will not teach all these things, sir, because so we have to learn something more, sir. We have to learn something more. So, but I know this, sir, how to remove outlier detection by using Mahalanobis also.
Okay. Thank you very much, sir. Thanks for the excellent. What is the technique, sir? I could not get clearly.
Mahalanobis. Here we are missing, no, sir.
Okay. Fine, sir. Thank you, sir. Thank you.
So go here, statistics. So you can see here Mahalanobis.
Okay, sir, can we take up another question from Dr. Vivek Gupta? This will be the last question for this session. Gupta, sir, you can start with your question.
Yes, ma'am.
Here, save Mahalanobis or cooks. All you can use. Mahalanobis, our own statistician, sir.
Okay, thanks, sir. Thanks for the excellent session once again, sir. Thank you.
Yes, sir.
Sir, just one small question. What is the difference between the standardized regression and unstandardized regression? Because as far as beta or the slope of the curve is concerned, that has to be one only, or there can be, two slopes for the same kind of, equation.
No, I will tell tomorrow, sir. I will tell.
Okay.
But see, it is not a standardized regression or unstandardized regression. It is regression only, sir. Standardized beta, unstandardized beta.
Yes. Standardized beta and unstandardized beta. Yes.
Okay. So, what is the use of standardized beta? How it is coming? I will explain, sir.
Okay.
Equation you have to write with the help of unstandardized, sir. So, standardized beta meant for some other purpose, sir. But you have asked something more in the end. That is wrong, sir. But I will explain what is right tomorrow, sir.
Okay, sir. Okay. Thank you so much, sir. Thank you so much. Thank you, sir.
Okay, madam, we will stop, madam.
Thank you so much, sir, for spending time with us. And
Rosini ma'am, just a second. Rosini ma'am.
Kashilingam, sir.
Yes, sir.
Sir, good evening, sir. Dr. Madhu here.
Yes, sir. Yeah, tell me, sir.
Informative, and I think, sir, one request is that can you please share this data sets so that
I will share, sir.
Practice.
Definitely, I will share, sir. I am sharing. First 2 days I have shared. After that, I have not shared. Okay, so I am busy.
Yes, sir.
The entire day, morning, going here and there. So
Okay.
Find time to
I know.
So today night also I am traveling to Tevagotai. So immediately after reaching home, I will be leaving to bus stand. So tonight also I may not share. Tomorrow afternoon I will share, sir.
Definitely, sir. Okay, sir.
Definitely I will give, sir. Definitely I will give. Then only you can perform. Okay, you perform with data. PPT will be there. PPT will give the process. If you look at this PPT, it is, for example, the regression PPT. Okay, so fantastic PPT, sir. Fantastic PPT, right? All process is explained, where you have to go, what you have to click. All I have explained. What is the output? All
yes.
I have explained, sir. You can see. So okay, so many.
So thank you, sir. Thank you very much.
Yes, sir. I will share, sir. Yeah, next, sir. One more person.
Yeah, okay, sir. Thank you very much, sir. It is very informative. Thank you very much, sir.
Then anybody else?
Sir, I have a silly question, sir, actually.
Why with this adjective and other things?
Because, no, sir, what is meant by T in t-test, sir? I don't know whether it's a valid question or not.
Tell again, madam.
What T stands for, sir, in t-test?
T-test T.
Sir.
T is T, sir, madam. See, the one gentleman, okay, so I do not know his name. He said it is student T. He has given the name.
Okay, sir. There is no like ANOVA is analysis of variance, no? There is no expansion for T, right, sir?
Yeah, it is student T. It is student T. He has given that name.
Okay, sir. That's why I told it is a silly question, sir.
No, it is good only, madam. You are thinking, you are giving the supporting answer also. For analysis of variance, we are giving ANOVA. Okay, so why we should not give this some name like that? Why they have given T, right? First person who has done this one, he has given that name.
Okay, sir. Thank you so much, sir. So one more question is there.
Yeah.
You have answered it partially when somebody else has asked us. Actually, how can we convert the continuous variable to categorical variables, sir? Is it possible?
Yeah, definitely possible. Tomorrow, definitely I will teach.
Sir,
definitely I will teach. Okay.
And one more question, sir.
Now itself, I want to teach actually that the age of the employer, if you have seen, okay, so if you have seen, okay, I have converted that data is also adjacent to me, okay, but today later we will discuss tomorrow. Yes, madam.
Sir, in the same data analysis, can we use one variable as categorical in one test, and in another analysis, can we use it as a continuous variable? Is it possible, sir? Is it valid to do like that? For example, sales and salary, sir. We are using both our metric. Suppose we are considering, salary and savings. Both are metric, salary and job satisfaction. In that case, can we use salary as a categorical variable and job satisfaction as a continuous variable? Is it possible like that, sir?
No, madam. You are using different variables. So for different variables, you can perform different analysis. Nothing wrong, right? Right. So for one analysis, right, you have used salary as a metric variable or continuous variable, right? In another case, you want to use it as a category variable. Same thing cannot use, but if you convert a metric variable can be converted into category variable, right? After converting, that variable can be taken as a category variable, right? Converted to category variable. Same values. Okay, so now if you are a male, if for example you are female, okay, you are female, you cannot be considered as male, right? Not possible. So unless otherwise converted, right? See, if it is converted, okay, into category, then that category variable can be used as a category variable. Hello, madam?
Okay, sir, I got it. Thank you so much, sir.
If you are a female, you can be a female always, madam. Right, madam?
Yes, sir. Categorical variable cannot be converted to continuous variables.
Definitely, not possible.
Continuous variable can be converted to categorical variable.
Yes, madam. Yes.
And it can be used as a categorical variable in one test and as a continuous variable in another test.
Yeah, continuous variable as a continuous variable. Category variable as a category variable. Right, madam?
Converted category variable can be used as a
yes.
Converted continuous variable can be used as a category variable.
Yes.
Sir, I wanted to ask you one question. Can you allow?
Yeah, tell me, madam. Hello?
Sir, due to the time constraint.
Yes.
Hello?
Yeah.
Due to the time constraint, it's already 8:15. Can we take the questions tomorrow, sir?
Yeah, madam. See, no, absolutely no problem, madam. Already I am late, madam.
Okay. Shukma sir and Rohini ma'am, you can continue.
They are not there. The Rohini madam will take over. Nandini madam will take over.
Okay. Thank you so much, sir, for spending.
Yes, madam. Yes.
Thank you so much, sir. I hope all our participants are enriched with the knowledge of SPSS, and any more queries will be answered tomorrow. Sir is also going to continue with us tomorrow. So please wait for tomorrow. We'll be answering your question. A heartfelt thanks to our Kasalingam sir for spending his valuable time with us. Thank you so much, sir.
Today, how many days we have completed, madam?
8.
Sir, we have completed 8 teachers
8 days. 8
and we
days.
have
8
completed
days over, Oh.
Sir, very good evening, sir.
Good evening, Ji.
Sir, there is a valuation, therefore I didn't attend your session, sir.
Okay. So 8 days over.
Yes, sir.
2 days, sir.
Okay, ma'am. Conclude it, ma'am. Because there is a next meeting. We have to hand over the meeting.
Yeah. Please stop. Okay. Shall I leave? Thank you very much. We will meet.
Thank you.
Thank you.
Sir, your lectures are so informative and unique.
Thank you, madam. Thank you. Okay.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Sir, meeting is over, sir. Please conclude it. Nandini madam, leave the meeting. Satish sir, thank you very much, sir. Satish sir.
Sir, Satish sir.
Satish sir is there, ma'am. Everybody should leave the meeting, ma'am. Sir,
Yes, sir. I'll leave the meeting now.
Yes. I request all the participants, please leave the meeting. Sir, have another meeting. See, it's a humble request from everyone. If you have any question, tomorrow definitely sir will go into answer. Thank you very much, everyone. Satish sir, hand over to you, sir. Satish sir.